Mars, the red planet, has always fascinated scientists, astronomers, and dreamers alike. Once imagined as a possible home to alien civilizations, Mars is now one of the most studied worlds in our solar system. But beyond the captivating images of its red deserts and towering volcanoes lies one of the greatest mysteries of planetary science. Its climate. Understanding the climate of Mars is not just about predicting dust storms or measuring icy caps. It's about unraveling the red planet's past, understanding its present, and forecasting its future. Could Mars have once been like Earth? Could it have supported life billions of years ago? These are the burning questions NASA and other space agencies are trying to answer. The current Martian climate is controlled by a delicate balance of seasonal changes in its polar ice caps, huge amounts of airborne dust, and the constant cycle of water vapor between its surface and atmosphere. Dust storms, one of the most dramatic weather events on Mars, can grow so large that they engulf the entire planet, darkening its skies for weeks or even months. These storms don't just create incredible visuals, they shape how Mars' climate evolves and affect the ability of rovers, landers, and future astronauts to survive on its surface. But Mars' climate story doesn't stop there. By studying today's weather patterns, scientists can model what the climate looked like billions of years ago. That means the blowing dust, the frozen carbon dioxide, and the thin atmosphere we see today are all pieces of a puzzle that reveal how Mars transformed from a potentially habitable world with rivers and lakes into the frozen desert we see today. What is the climate on Mars like today? The climate of Mars is far from stable. It's dynamic, volatile, and extreme. Unlike Earth, which has a thick protective atmosphere that regulates temperature, Mars has a thin atmosphere made mostly of carbon dioxide. This thin layer of gas does little to trap heat, which is why temperatures on Mars can swing dramatically. During the day, sunlight can warm the Martian surface to nearly 20 degrees Celsius, 68 degrees Fahrenheit, near the equator. But at night, those same regions can plunge to minus 73 degrees Celsius, minus 100 degrees Fahrenheit, or colder. At the poles, conditions are even harsher, with temperatures dropping below minus 125 degrees Celsius, minus 195 degrees Fahrenheit. During winter, adding to this complexity, Mars experiences seasonal changes driven by its tilted axis, just like Earth. Its carbon dioxide ice caps grow and shrink with the seasons, releasing or capturing large amounts of gas. These seasonal changes don't just affect the ice, they drive winds, move dust, and regulate how water vapor circulates between the ground and atmosphere. One of the most dramatic climate events on Mars is the planet-wide dust storm. These storms are not just strong gusts of wind. They can grow so large that they completely enshroud the planet. The 2018 global dust storm, for example, ended NASA's Opportunity rover mission after more than 14 years of exploration. Dust storms can block sunlight, shut down solar-powered equipment, and change atmospheric temperatures across the entire planet. What does Mars' climate tell us about the past? Understanding the present climate of Mars is essential, but it's only part of the story. Scientists are even more interested in what today's weather patterns can reveal about Mars' past climate. Was Mars ever like Earth? Did it once have a thick atmosphere, flowing rivers, and stable lakes? To answer these questions, scientists rely on a combination of Mars, weather data, geological studies, and polar ice research. The polar regions of Mars, for example, hold layered terrain, much like tree rings on Earth. Each layer represents a different climate period in Mars history, recording shifts in dust, ice, and temperature over millions of years. NASA's missions, including the Mars Reconnaissance Orbiter, Curiosity, and Perseverance, have shown evidence that Mars was once warmer and wetter. Ancient riverbeds, dried-up lakes, and mineral deposits like clays and carbonates tell us that liquid water was once abundant. These findings suggest Mars may have had a climate more like Earth's billions of years ago. But what went wrong? Why did Mars lose its thick atmosphere and turn into the cold desert it is today? Many scientists believe the answer lies in Mars' magnetic field. Billions of years ago, Mars had a magnetic field that shielded its atmosphere from being stripped away by the solar wind. When this magnetic field disappeared, the solar wind slowly eroded the atmosphere, leaving behind the thin, fragile air Mars has today. How NASA studies the climate of Mars. Studying the Martian climate is no easy task. Unlike Earth, we don't have satellites, weather stations, or meteorologists stationed across the globe. Instead, scientists must rely on robotic missions, orbiters, and rovers. Mars rovers Curiosity and Perseverance. These robotic explorers act like mobile laboratories, measuring air pressure, humidity, dust, and temperature. They also analyze rocks and soils that can reveal how Mars' climate shaped the landscape. Orbiters, spacecraft like NASA's Mars Reconnaissance Orbiter, MRO, provide high-resolution images and track changes in the atmosphere over time, allowing scientists to create Mars weather maps. Polar studies. By studying the layers of ice and dust at the Martian poles, scientists can reconstruct past climates and compare them to current data. Future missions. NASA's upcoming missions will continue monitoring the planet's atmosphere, with a focus on how dust storms begin, grow, and spread. This research will not only help us understand Mars, but also protect future astronauts, who will face these challenges firsthand. Was Mars ever like Earth? Perhaps the most intriguing question of all is whether Mars was once more Earth-like. Geological evidence strongly suggests that billions of years ago, Mars had liquid water, a thicker atmosphere, and possibly even conditions suitable for life. If Mars once had a climate similar to Earth's, it raises profound questions. Could life have originated there? If so, what happened to it? Did it adapt and move underground? We may not only uncover the red planet's secrets, but also gain new insight into our own planet's future. Climate change on Earth is a pressing issue, and by studying how Mars lost its atmosphere and water, scientists hope to better understand the fragile balance that makes Earth habitable. Why Mars climate matters for the future of space exploration. The climate of Mars is not just a scientific curiosity, it's a critical factor for human exploration. NASA's Artemis program aims to return humans to the Moon, but Mars is the ultimate destination. To send astronauts safely, and seasonal changes will affect equipment, habitats, and survival. Solar-powered rovers like Opportunity have already shown the dangers of dust storms. For future human missions, dust will be more than an engineering challenge. It could also pose health risks if inhaled, or if it interferes with life support systems. Understanding the Martian climate is therefore essential for building sustainable colonies on the red planet. Conclusion: unlocking the climate mysteries of Mars. The climate of Mars is one of the most fascinating and complex puzzles in planetary science. From planet-wide dust storms to ancient polar layers that act like time capsules, every observation brings us closer to understanding the red planet's story. By studying Mars' climate today, we can unlock the secrets of its past, prepare for future exploration, and even gain insights into the destiny of Earth itself. Mars is not just a cold desert world, it is a laboratory of planetary evolution, a window into climate change on a cosmic scale, and a reminder of how fragile and rare habitable environments are in the universe.